Hello, my name is Aiki. In this video, I want to talk about finite state machines, also known as FSMs, and how we can use them in our project to control game behavior. What is a finite state machine? A finite state machine helps a game object or unit understand what's happening and what it should do in each situation. Instead of writing many if or nested if statements, we can give the game object a state. When the state changes, the unit's behavior changes automatically. This makes the code cleaner, easier to read, and easier to maintain. For example, in a real-time strategy game, a unit can be in states like idle, chasing, attacking, or dead. So what's the idea? At its core, an FSM is built on two simple rules. First, each state represents one clear behavior. Second, a unit can only be in one state at a time. When a specific condition is met, the unit transitions from its current state to another state. This clear separation of behavior makes the logic easy to understand. To keep states consistent, each state follows the same structure. Every state has three main functions. OnInter runs once when the state starts. OnTick runs every frame or update. OnExit runs once when the state ends. This structure allows the unit to set up behavior when entering a new state and cleaning up when leaving it, such as resetting the timer or switching animations. Now let's take a look at how transitions work. A state transition knows which state we should go next and what condition must be true. For example, a unit should only attack if it is close enough to the enemy, usually after chasing it. Each transition uses the conditions that returns true or false. When the condition becomes true, the state machine switches to the next state. So what's the main logic? The state machine is responsible for managing everything. It knows all the states and all transitions between states. It also should support any transitions which have the highest priority and can happen from any state. For example, if a unit's health reaches 0, it should immediately switch to the dead state no matter what it was doing before. When switching states, the order of operations is very important. When switching, we must 1. Call OnExit on the current state. 2. Set the new state. 3. Call OnInter on the new state. This ensures that animations, flags, and behavioral update correctly during the transition. In the main loop, every update or frame, the state machine follows the same process. 1. Check if any transition is triggered. 2. Changes state if needed. 3. Runs on tick on the current state. The any transitions are checked first. If not valid, then we check transitions from the current state. Let's take a look at a simple example with 3 states: idle, chase, and attack. And here are possible transitions: idle to chase to attack to chase, and attack to idle. From idle to chase, we have a condition that happens when the enemy is detected within vision range. From chase to attack happens when the enemy is within attack range. Attack to chase happens when enemy moves out of the range, and attack to idle happens when the enemy is killed. As you can see, each state focuses only its own behavior, while transitions control when behavior changes. To summarize, a finite state machine avoids complex if statements, easy to understand and implement, and works well for a small number of states. However, as behavior becomes more complex and the number of states grows, FSMs can become harder to manage. In those cases, we should consider advanced systems like hierarchical state machines or behavioral trees. Thank you for watching. If you find the video helpful, please give it a thumbs up. If you would like to support the channel, you can find the links in the description below, and I will see you in the next video. Bye bye.